You said it makes the what? Okay, so it's the making of the protein, and it's based off of code that's supplied from what? From the mRNA. So, in translation, we could say that mRNA is read. And how many bases at a time? Which is a codon at a time. Okay. Where's this occurring at? Okay, so this happens at the ribosome. And for each 3 bases, what is that code for one of? Okay, so each amino acid added to the growing chain, or added to the growing peptide, is encoded in 3 bases. So this means that we need to talk about or discuss a mechanism of how we're able to get those amino acids to this point. So we'll need to discuss the role of tRNA. The T there stands for transfer, so this is transfer RNA. And its function is going to be to carry amino acids to ribosomes. And what I want to talk about today is just the structure of a tRNA molecule. And there's 2 different ways to draw it real quick. So I'm going to get you to draw down this picture, minus all the little boxes. So really I just want something that has this type of a shape. Really what I'm looking for. We could label the ends of this as well as being 3' and 5'. And this area down here leaves room for 3 bases. These 3 bases that are right there are collectively known as the anticodon. The anticodon. So that means that this anticodon is going to have a purpose or a role in matching up with the codon on mRNA. So it's going to match up with the complementary codon of or on mRNA. That means if this anticodon is AAG, then the codon is going to be UUC, because the mRNA would only have U, right? Good. So let me show you a different picture real quick. Can I move this? Okay. Actually, before I do that, I want you to add something. This right here, this open space, is the amino acid binding region. It's where the amino acid is binding. Remember, there's 20 different amino acids. And we're adding one amino acid at a time based on a codon to this growing polypeptide chain. Right? Here's another way to describe or to show a tRNA molecule. That would mean that what they're trying to show you here, this region up here where you could connect an amino acid. How many different amino acids are there? 20. And each one of these is going to bring one at a time. Let's say that this tRNA molecule, because that's what we have here, we have a tRNA molecule. Let's say that it had an anticodon, which of course would be right here. And let's say that its anticodon was G UC. GUC. That's the anticodon, correct? Well, this is going to match up with a codon on mRNA. And what would be complementary to this anticodon of GUC? CAG. Would there be any thymines in a codon ever, if you think about it? No, because T is never in an RNA molecule. Remember, your mRNA, we read 3 bases at a time. There's the prior 3, and there's the prior 3. There's a codon, there's a codon, and there's a codon. Now let's go back and let's say that maybe this codon that's one to the left was UCG. Okay. So what tRNA molecule would bind to it? What would be the anticodon of the tRNA molecule that was to bind to this piece? So A, G, C. Perfect. Now if we go back from a couple of days ago, and we remember that we have this, which is our this shows which different amino acids are being brought by which different codon. The codon right here is CAG. Okay, so we would look for C, then A, then G. So this would be glutamine, GLN. So I should actually write that this amino acid up here isn't just any amino acid, it's the glutamine amino acid, GLN. And if this was a tRNA molecule right here, then what amino acid should I be looking for on this one? Should I be looking for AGC or UCG? Yeah, UCG. Because we're always looking at the mRNA codon. You'll know that by looking at your codon chart. You see how it says mRNA? So we know we're looking at mRNA. UCG is going to be which one? Serine. So I could expect this amino acid up here to be a serine amino acid. SER is the symbol or the abbreviation for serine. A different type of amino acid. Good? Okay, so when we start back on Monday, which is the day before the test, as a reminder, we have to talk more in detail about a couple of things. One is, what's the process of getting these amino acids carried by these tRNA molecules dumped off? And then two, we also have to describe a mechanism by which we can recharge our tRNA molecules that are carrying all these amino acids. We need to reload them once they've dumped it off. And then we need to really finish the product of making sure that we've got everything set at the ribosome so that translation goes perfectly. So I suspect Monday will take us a majority of the time. My strong advice would be that you are reading the chapter, because we're going to go through this very quickly on Monday. But there's some videos that I think you really need to see, so we'll watch them real quick.